what expression? 1 minus what? Chan? Well, if I factor x from the top, I factor x from here and here, I'll be left with this parenthesized expression, which will read 1 minus what? 1 over x. Good, 1 over x. What does the bottom read? 1 plus 1 over x. Okay. So now you guys know how to factor something when it doesn't have that factor, right? 1 does not have x in it. So whenever you take a factor from something which does not clearly have that factor in it, you just divide by it. That's all you do. So for example, let's say you have 5 minus 8. You want to factor 2 from that, okay? What would you write in there? 5 over 2 minus, that's right, 5 halves minus 4. And that is the exact same thing, of course, okay? Works with numbers, it works with letters. All right. Now we have that ratio. What can you cancel that ratio? Those highest powers of x pulled out, right? So I'll just do that with an eraser instead of writing the next step. There, we have that, okay? So now as x goes towards infinity, what happens? Well, 1 heads towards 1 because it's constant, it's just 1. But what about this little guy? What's 1 over x heading towards as x goes towards infinity? 0. This little pest here, he's heading towards 0. What's this one heading towards? The same thing. So what is 1 minus something really close to 0 heading towards? 1. What is 1 plus something really close to 0 heading towards? That's the answer, 1. So it's always ratio within coefficients. But this is going to apply to those cases even when you have a radical in there, or some other nonsense, all right? Not just the rational case. You guys hold all right?
Not for me.
No?
I just got out of my chem lecture and lab this morning.
I just got out of 6 kids a minute ago. Trust me, I got the harder job, all right? All right, let's see. 42. Is 42 a rational function? F of x equals the square root of x squared plus 1 over 2x plus 1. Yep. I want to take the limit as x goes towards, it's the same thing twice. I think they, oh no it doesn't. No, okay, this is different. Take 2 limits. 1 as x goes towards positive infinity, and 1 as x goes towards negative infinity. Rational function, yes or no? Rational function? No. No, they're not polynomials. The top one's not a polynomial. It's a polynomial stuffed inside something, which is not a polynomial. Let's just set another polynomial. All right, so we cannot apply the 3 rules we just talked about. So we've got to use the technique I just mentioned over here. We've got to factor out the highest power of x. So now you have to be a little careful. This radical affects what the highest power of x is here, right? Highest power of x above looks like x squared. It's not really x squared. Because if you took that piece by itself, if you took the radical x squared like this by itself, now don't forget the plus 1. What power is this really? X to the first. So that's the power you really want to deal with, all right? So really the highest power up here is x to the first, and the highest power down here is also x to the first. So we're going to factor off x to the first. All right, we're going to factor off a single power of x from top and bottom. All right? Lim as x goes towards infinity, when I factor off an x from the top, the bottom is ridiculously simple, right? Now that I showed that thing a second ago, x is just 2 plus 1 on x down here, right? That's no big deal. What about the top, though? When you factor off x, it means you're factoring x squared from the inside, right? X squared inside is an x outside, right? So when you take an x out of this thing, you're really taking an x squared from inside here. So it's going to be radical 1 plus 1 over what? X squared. You're taking a square from the inside, which makes it a single x on the outside. Okay? If we show that in slow motion, it would appear like this. X squared, 1 plus 1 over x squared. There. And then this would be like that. And then it would read like this, like we just decided. Okay? That's the logic why it's an x squared in the denominator inside.
Wait, so you pulled out the x squared and then you're still left with 1 over x squared?
Yeah. Does this not make it clear?
Okay. She explained it.
Yeah, fine. Okay, so now you cancel the x's. There you go. Okay. So now as x goes towards infinity, what happens to the top? The 1 is the 1, and this is heading towards, that little part's heading towards 0, and this little part down here is heading towards 0. So what are you left with? The square root of 1 over 2, which is 1 over 2. 1/2. What did you say, Cornejo?
I don't, can you show how you got to the square root of 1 over 2 again?
Yeah, I'm just simply considering the fact that of these two additive pieces here, this one is constant, so nothing's happening to it. This one, what is happening to it? The x is heading towards infinity. So the bottom is getting extremely large. 1 over extremely large, 0, heading towards 0. So the top is heading towards 1 plus 0 inside a radical, which is the same as 1 inside a radical, which is the same as 1. And the bottom is the same basic idea, right? This part here is heading towards 0 because the bottom is becoming infinitely large. 2 plus that is just going to be the 2. That's the bottom heading
So
toward.
left with the rooted to 1 over 2 gives us a half.
That's right.
Yep.
Any questions?
Are we almost done with 2.5?
Yeah.
Okay.
Yeah.
A few more practice problems, right?
If you want. Those are the main, I just showed you the main ideas. Now there are some functions that you should be aware of their in behavior. Even without taking any limits directly, you should be aware of them. From pre-calc, you should know them. It would be very helpful throughout the rest of the class to remember these. So I'm going to graph them very quickly, and you will see the in behavior in the picture. What function have I just drawn? Is that exponential function? Some sort of exponential function. Good answer. I'm going to call this e to the x in this case. Okay? It's 1. It has a horizontal asymptote. So now, I'm going to write some limits up here. I want you to tell me the answer to the limits just based on the picture alone. So, limit of e to the x as x heads towards negative infinity. Limit of e to the x as x heads towards infinity.